So the last number we'll talk about is 380. 380 is the most voted on Jira case number. It is the feature I get asked about more than any other feature in the last 4 years. And so the server 380 is text search, basically being able to have text search embedded in Mongo. And what does that actually mean? It basically means that people want something that is fully integrated, right? You want to be able to store blog entries in Mongo and be able to search for things in a fairly natural way. And you want it to be simple, right? You want it to be able to say, hey, I just want to create a text index on this in Spanish and not have to go up and implement a whole second stack. Right? I don't have to, right now it's very hard because you've got to take Mongo, you've got to hook up something to it, and you've got to do all that work. And then you've got 2 systems to run, which is obviously challenging. A lot of people have also asked for something that is fully consistent, right? A lot of the external solutions, what they do is they'll take Mongo and they'll replicate Mongo into something else. And that's pretty good for some things, but it's also not fully consistent, right? So if I go and add a new blog post, it may take 5 minutes or a couple of hours for it to show up in my search index, which is definitely not ideal. And one of the things we thought a lot about is, this is not going to solve every search problem in the world. We're not trying to build something, we're not trying to replicate Lucene, we're not trying to build a whole new search system. What we're trying to do is build something that covers 80% of the use cases. I've got a blog and it's written in Mongo, or I've got an e-commerce site and I want to search for products, where the search is pretty simple, but you want to be able to do some basic things. So let's take a look at how it works, and then we will, in the process, we can talk about a couple of other features. So first, I am going to spin up this is on a machine. I'm going to spin up a small 24-shard Mongo cluster on a dev machine we have. So we'll just let that spin up. And one of the features that is coming out in 2.4 in addition is hash shard keys. So this is another feature that people have been asking for a lot. And just to back up for a second. So sharding in Mongo is range-based. So if you have a 24, or let's make a 26 shard cluster, and you shard on last name, the way it would work is it's like a phone book. If your last name starts with A, you go to one shard, B, another shard, C, another shard, which is great for a lot of use cases. But sometimes you want to just distribute things completely randomly, right? Well, not randomly, but you want them completely evenly distributed. You don't really need sort of the ranges to be consistent. You just want to be like, hey, this document lives somewhere, and so it's a feature called hash shard keys, so which is coming out in 2.4, and so we can do it. And basically what that means is, as soon as you turn on sharding with the hash shard keys, you get perfect distribution of data and perfect data distribution of load. So we're going to say shard collection and a little precursor. I'll say test.enron. And we're going to say, normally you would say this, which is basically to shard your collection on _ID. Now if you want hash shard keys, you change that to hashed. So now it's going to create this as hashed, and what you can see is that instead of having, for people who've used sharding before, instead of having one chunk on a single shard, you've got 2 chunks on every single shard, so your data is distributed very evenly, instantaneously. All right, so now we've got this set up. So now we need to import some data. So let's go ahead, and we've got the Enron email data set in BSON format. It's about 1.4 gigs. So we can go ahead and import that. And this will be pretty quick. So right now there's no search on it at all. Right now it's just importing the full 1.4 gig data set. Okay. So now we can go look at it. And what we'll see is that you've got all these shards, and the number of documents per shard is pretty consistent, right? It's about 20,000 documents per shard, and it's all very evenly distributed. Okay, so that's pretty nice. So now we've got perfectly evenly distributed data set. We were able to import the 1.4 gigs in about 10 seconds. And so now we're ready now we want to search it, right? Now we want to actually see what's in this data set. So now we want to create a text index. So we're going to create an index just like any other index. But instead of saying 1, we're going to say we want to index the body as text. and we want to index the subject as text. And so now this is going ahead and creating a text index. And this will take about 1 minute. And so while we do that, let's just take a look at what text search actually is. So let's make a little simple example. So let's say you've got posts, and I'm not sure if I have any old data lying around. So let's go and insert some documents into Mongo. So we're going to have a title of Welcome to Mongo SV. And text of Mongo SV will be a lot of fun. Oops. Okay. Now we're going to create an index on this, same way. Sorry. All right. Now we can do a search. And we'll add some helpers to make this easier, but basically we can search for Mongo SV. And then it will basically give you a search, and you get scores. And you can do some interesting things with this. You can do things like negations. You can do phrase matchings. Currently it supports a lot of Latin language, so it does a lot of the European Latin languages, and it will basically do basic splitting and stemming of words. And so if we had running and running, it does all the right things. All right, so we created our nron index. So now if we go ahead and look at this index, we'll see that so the data size is about 1.4 gigabytes. The text index on the full body and the subjects is about 2.6 gigs. And so now we can search it, right? So we can do a simple search. And we get some results. And to make this a little bit easier to look at, we built a very tiny UI, which you can actually all hit from your, it's already running apparently. So you can, if you go to, you can tell where this is running. It's running on my desk. If you go to office.tengen.com, port 3333, you can actually go ahead and do a search. So you can search for grandma, you can search for all sorts of things, and I think this works too. Oh, that doesn't work. The internet is a little slow. You can search for you can basically just go to this and search for search the entire Enron email data set pretty simply. So what does this actually mean? So as I said, this is pretty simple. It does support lots of languages. It supports negations and phrase matching and negative phrase matching. And what we really need the most to actually figure out what to do with this feature is help. We need help testing it, and we need help sort of understanding how people want to integrate search with Mongo. This is the most requested feature in Mongo. It has been for almost 3 years. But what we need a lot of now is like data sets that help test and examples to use. And what I think is going to happen is this is going to probably go into 2.4 as an experimental feature so that you can try it and so we can get a lot of learning from it, and then so we can figure out exactly what features we need to add to it over the next couple of years to make it something that people can really use for a wide range of applications. Overall, we're pretty excited about it, and we're pretty excited about hash shard keys because that does make a lot of deployments and a lot of the administrative things a lot simpler. So if you do want to bring up a very large sharded cluster, it is much simpler to get going. And especially if you want to import a lot of data very quickly. Right? The best thing about it is that if you've got a huge data set and you want to import it evenly throughout your entire cluster as fast as possible, this makes it considerably easier to do.